Hi, this is Marathon Man. This is the second video of the series that I'm going to be conducting. We're going to be talking in this series about the primaries and the secondaries relationship. And I'm pretty confident that after I finish this video, you will have a very clear understanding of the primary-secondary relationship in the Figuera device. We're going to talk about the north-north, south-south dilemma, expelling all doubts of the orientation. It's extremely physics-orientated. I have all my information that is brought off a physics website, so there is no doubt in my mind that nobody can discredit this or deny it, because if they do, they need to find another avenue or job, because this is straight off a physics website. And I also want to talk about the spin direction, induced directions, and the E field direction. Actually, E field direction and intensity. And I want to also include William Hooper and his connection with the Figuera device. So let's get started. Alright, here we go. The camera's a little shaky, but it is what it is. I don't have anybody helping me. Alright, the induced magnetic field is upward to oppose the flux change. To produce this induced field, the induced current must be counterclockwise as seen from above the loop looking down. Here's the magnet coming in, here's the induced, here is the current rotation. It is from counterclockwise, from right to left is looking from above, but it's actually clockwise when you're looking at the end of it. Okay, this is exactly the same thing as the current increasing in the primary. You still have the same thing. You have the induced field in this direction opposing the magnetic field coming in. You have the current going in the same direction, which is counterclockwise, and looking at it from the end, which is clockwise. Okay, now come over to this side. This is the exact same, except the magnet is coming out. The induced is in the opposite direction, and the current is in the opposite direction. And this is the same thing as an electromagnet. It is exactly the same thing. All you are doing is raising and lowering the current. That's all you are doing. The induced magnetic field is downward to oppose the flux change. To produce the induced field, the induced current must be clockwise as seen from above, but if you look at it from the face of the coil or the magnet, it is actually counterclockwise. Okay, both B fields are opposing, but induced are in the same direction, causing a double motional electric field as opposed to one electromagnet alone. Okay, now all we did here was take this and turn it sideways. Then we took it and placed it here. Then we took the decreasing electromagnet, we grabbed it and turned it here and put it to the other side. Now, look at what we have. We have one electromagnet or magnet coming in with the induced in this direction. We have an electromagnet or magnet going out with the induced trying to oppose to keep the current going in the same direction. Okay? Look what we have. The current of both of them is in the same direction. What I've been harping for over 2 years. The current is in the same direction. But here is a word of warning that I will get to you in a second. The production of the spatially distributed electric fields arises from the operation called flux cutting, wherein the electric field is motionally induced from both electromagnets within the space occupied by the moving magnet, whether the secondary conductor is there or not. If kept in complete unison, the electric fields merge as one larger field, as both induced are in the same direction with B fields in opposition. As long as both are in complete unison, the larger electric field will remain to be collected by the secondary. This is the Figuera device all day long. When you have one coming in and one coming out, the B fields cancel. The magnetic fields are always opposing. But since you are pulling one of the magnets out, you're catching the back side of the spin. I don't care what anybody says. There is particles involved because you can't put a magnet in and pull a magnet out and it go into a different direction and there's not something spinning. Something minute that we cannot see. But I'm not going to go there. I'm just going to deal with what we have. This is straight off a physics website, people. Both induced are in the same direction while the magnetic fields have pressure between them. They will never connect as one because their magnetic fields are opposite. They're opposing. But the E fields are not. The E fields, what is happening is the E field is curling around this direction. It's curling this direction around the secondary coil. Now, when this goes this direction and this one goes this direction, the E field curls this direction to us, not this direction. This way goes this direction. This way goes this direction. It spins this way. Now, a word of warning about the B field concept. The change in B field does not really induce an induced field. What really does is create a circular field, and that is which drives the current in the loop. The induced B field is a fictional construct which makes it easier to figure out the direction of the current. Now, this is the Figuera device all day long, and I will talk about why NS cannot be used in any way, shape, or form in the Figuera device. And here you have a north-south orientation that cannot take place, will not take place ever in a Figuera device. Here you have a north magnet coming in, you have the opposition to the magnetic field coming in, right? This is the induced. The induced is in this direction, same thing as before. Here you have the current flowing in this direction. Now, let's look at the south magnet. A south magnet going out will have an induced in this direction. Did you notice it's opposite of the north magnet coming in? Wow, imagine that. Now let's look at the induced. The induced is this direction and in this direction. What are those two signs? They're opposite from each other. It can't happen, folks. A north and a south magnet in a Figuera device will not happen because they try to combine. Why? Because both their B fields are in this direction. They're not opposing. Both B fields are this direction and both currents are opposing. And because of, what's his name? I can't remember his name. He said there's a dielectric avoidance here, and this one has plenty of dielectric coming out of it. So you are going to have both magnets combined. You will not and cannot have a north magnet and a south magnet in the Figuera device. It will not happen. What you have, according to Walter Russell, is the way that we wind our coils, we automatically lose 50% to magnetism from the way we wind our coils. So automatically, this is already reduced to 50%. Plus, you have this one fighting it. And you're reducing this one to 50% in the Figuera device. You never go below 50%, otherwise you'll lose induction from one of the electromagnets. And that's what you don't want to do. So automatically you're losing 50%. Okay, 50%, from starting for 50%, you minus 50% from that, you have 25%. So by using a north-south magnet, you will get 25% out of the device from 100%. It cannot happen. With both devices being NN, both electromagnets, you will attain your 100% E field back again. That's what I've been trying to say for 2 frickin' years. Both fields are opposing. The currents are opposing. That is why you cannot and will never have a north-south magnet in the Figuera device. And here's another one of my graphs that I posted almost 2 years ago. This is exactly the previous depiction of what I was trying to show people. It shows the induced, both of them in the same direction, but B fields opposing. One is increasing, one is decreasing. What it causes is a double E field because both are induced. They complement one another. Both of them are in the same direction. And then when you put it the other direction, taking this one, decreasing this one, increasing this one, your B fields are still opposing, but your induced is in the other direction. This is exactly what I've been harping on for over 2 years, people. The double motional electric field. You get double the intensity because both of them are additive. You can't do that with the north and south face magnet. It will not ever take place because the induced are in 2 different directions and the B fields are in the same direction. It will cause them to snap together and it will not happen. They always try to fight to come together. With the north-north setup, it won't happen, but you're catching the backside of the spin of one while you're decreasing it, which causes the reverse E field. They both are together, people. And this graph right here is well over right at 2 years old. 2 independent primary magnetic fields occupying the same relative space in space, operating in complete unison. One increasing, the other decreasing, will cause the formation of one large E field as both inductance are in the same direction, complementing one another. Y coil, or rather the secondary, is there to collect the electric field. In the 2 patents can be seen how ingeniously and mechanical methods the engineer tried to generate the electrical energy inside a coil by varying the flow of 2 opposite and opposing magnetic fields, trying to get into the machine the same characteristic behavior as a conventional generator but without moving parts. Fellas, he did it. He had this working in his device. It might have been his 1902 patent, but he redefined it. The 1908 patent was his glory, but he died a couple of months later. But that's okay because Clemente Figuera, this is Clemente Figuera all day long. Clemente Figuera had this device working in his house, people. And I just showed you the physics involved. There you have it. And here we go with William Hooper. William Hooper did a tabletop experiment that proved the validity of the Figuera device. And how do we know? Because he did a simple lecture table demonstration in front of a crowd of people multiple times and proved the validity of the Figuera device. Why is this just like the Figuera device? Because you have one electromagnet or magnet coming in with the spin direction in this direction. You have one electromagnet coming out with an opposite spin direction. It is just like the Figuera device. The only difference is the electromagnets are turned this way. You can actually do this with the magnets and test it. Turn the magnets this way, turn this one this way, and get the same exact results. You can even do it with 2 electromagnets on at the same time and vary them back and forth on a stick. You get the same output. you have two sources of B and V. One BV, one minus BV. It's the same thing as the Clemente Figuera vice. When you're taking one in, you're taking one out exactly at the same time in unison. It causes a double motional electric field. Note that in this sample experiment, we have two sources of B times V. Both the B and the V of each source are identical in magnitude but opposite in direction. Therefore, since B times V equals minus B times minus V, the products are both positive and additive. The movement of one magnet alone will be found to yield a galvanometer deflection of half that attained by both magnets when both magnets are moved simultaneously. Note that the wire is always in a region where B equals 0, but where B times V is present and active. Folks, this is straight up Clemente Figuera device all day long. Now, I may not agree with his patent that he had. I think it's entirely different from this, but he just did this to prove a point, and this is exactly the Figuera device all day long. Whether anybody likes it or not, look at it. It's exactly Figuera device. That's why I included William Hooper in it, because it is the Figuera device. It's the same thing is happening in the Figuera device is happening in William Hooper's tabletop lecture demonstration. Hi, this is Marathon Man again. I hope you've enjoyed this video. I hope in your mind that I've proven without a doubt that it's north-north face in the Clemente Figuera device, and also cleared a few things when it comes to spin direction and induced direction. I wanted to add some more in the video about the primary and secondary interactions, but I think I'll save that for another video and keep that just for one video alone. I guess this will close out this video, and I hope everyone's enjoyed it and learned something from it. And until next time, happy Figuering.